This is Antoine de Saint-Exupéry. He was a French aviator and author. He is best remembered as being the author of The Little Prince, which is an amazing children's book. But he wrote other books as well, one about aviation. And his book on aviation contains a wonderful quote. He says, "It seems that perfection is obtained not when there is nothing more to add, but when there is nothing more to subtract." It's absolutely brilliant. He was talking about the design of airplanes, but people have applied that to all sorts of other activities, like architecture, design, engineering, anything that involves creativity and discipline, writing, lots of things. And it seems to apply especially to programming, because programming has this special requirement for perfection. And Antoine is suggesting a way that we can achieve perfection. A program that's not perfect is a bad program. So we're trying to get perfection, and he suggests that you get perfection by removing things, by subtracting things. This would also seem to apply to programming languages, that there's a tendency to try to make programming languages bigger by adding more and more features, but he suggests that maybe we try to make them smaller. And that's the principle of good parts, that we remove things from a language, making it more perfect as we do so. Now the good parts, something I've written about it, it's still a controversial feature. The principle of good parts is this, that if a feature is sometimes useful and sometimes dangerous, and if there is a better option, then always use the better option. This is a controversial idea. A lot of people say, I don't want to use a better option. I want to use a dangerous option, which I don't think makes sense, but you hear a lot of people saying that. And it's due to this confusion. We are not paid to use every feature of the language. Some people seem to write programs as though that were true. Now, that there's some managers who will look at it, use a go-to, just look, did you use every bad thing that's available in the language? Did you do it? Are you doing your job? Turns out, no, that's not a good way to write programs. We are paid to write programs that work well and are free of error. And when did this free of error thing happen? It turns out free of error has always been the first requirement of software. It's just that we achieve it so rarely that it's easy to forget that that's the first requirement. But it is, it's still the first requirement. Now, I recommend that people learn as many languages as they can, because every good language will teach you something. And the things it teaches you, you can apply in working with other languages as well. I've seen some people coming out of university knowing only one language. And I think that's tragic. That's so sad. I don't think you can call yourself a professional programmer if you're only fluent in one language. You should learn a lot. And even JavaScript can teach you things. JavaScript taught me a lot of things, but it took me a long time before I learned how to learn from JavaScript, because I made every mistake with JavaScript that you can make. Starting with the first one, the worst one, I started writing JavaScript without bothering to learn the language first. That turns out to be a really common error, and it's a big mistake. You can't learn a language until you've learned the language. You can't use it well until you've learned it. So the other thing that taught me a lot about programming and JavaScript was JSLint. JSLint was a program I wrote which is aware of all of the terrible problems in JavaScript and warns me about them in my own code. I wrote JSLint for me so that I could write, because I don't dare write in this crazy language without having this kind of verification of the code. And JSLint taught me a lot about programming. My ideas about programming style completely changed after working with JSLint. So I wrote a book about my experiences with JavaScript and JSLint called JavaScript: The Good Parts. And I'm very happy to report that although this book was published in 2007, I think, or 2008, it's still a bestseller in its category, which is very unusual. It's very rare that a technical book on software stays current for more than a couple of seasons. And it's because the good parts haven't changed. You know, what's good about the language will always be good about the language. So I've been an advocate since then of programming only with the good parts of the language, of any language. Every language has good parts and bad parts. Whatever language you're writing in, you should only use the good parts. And there are arguments against doing that. And I think it's interesting to look at these arguments. The first one is that it's just a matter of opinion. What's good or what's bad, you know, no one can know for sure. Anybody can have their own idea about what's good or bad. It turns out it's not a matter of opinion. So I am the maintainer of JSLint. And so I get bug reports from people all over the world. You know, sometimes they'll tell me, we spent weeks tracking down this weird thing in our code, and it turned out to be due to this weird corner case in JavaScript. You know, if you could put a test in JSLint that would warn people about that kind of stuff, it could save a lot of time. And I'll look at their advice, and if it makes sense, I will incorporate that into JSLint, which means if you're using JSLint, you will never have to waste those couple of weeks chasing down that bug. That's not a matter of opinion, that's fact. There's the idea that every feature is an essential tool. You need every tool available to you to do programming. And that turns out not to be true either. That any feature of the language, which it turns out if you don't use it, you end up writing better programs. That is not an essential tool. It's unnecessary. It's a distraction. I have a right to use every feature in the language. We have now changed the debate, right? We're not talking about what's the best way to write programs anymore. We're talking about our fundamental rights to make mistakes. And going through that argument, there's no way we'll ever get back to how to write programs. I need the freedom to express myself. Now, programming is a creative activity, but some people think that the creative aspect is in the way that they actually compose the code. And that's, you know, that I need to put the semicolons at the beginning of the statement instead of at the end in order to express myself. And that's just silly. I need to reduce my keystrokes. We have a tendency to think that we spend most of our time typing. You know, what did I do today? I was typing. And it turns out that's not how we spend most of our time. We spend most of our time staring at the screen trying to figure out why isn't this working. So anything in which we try to reduce keystrokes, which increases the time that we spend trying to figure out why that didn't work, that's a bad trade-off. You don't want to be doing that. If you had to increase your keystrokes 10 times over what you're typing now with the guarantee that your programs will always run, that would be a huge, huge, huge benefit. Nobody can promise that, but I'm just saying if that trade-off ever became available, it would be a good one. It's an insult to suggest I would ever make a mistake with a dangerous feature. That's just silly. Oh, and then finally, there's a good reason all of those features were added to the language. And that turns out not to be true. So the designer of JavaScript, Brendan Eich, he was given 10 days to design the language. And he did some brilliant things in those 10 days. And he made some terrible mistakes in those 10 days. Ended up putting a lot of features into the language that he now refers to as foot guns. A foot gun is a gun that you use to shoot yourself in the foot. And he doesn't recommend that you use foot guns. And as we improve the language going forward, he argues against putting more foot guns into the language. There's some people who think, I have a right to use foot guns, and I almost always miss. You know, so it's okay. But it's not okay. So the purpose of a programming language is to aid programmers in producing error-free programs. And if there's anything in the language which is inducing you to create errors, then that's a bad part, and you would be better off not using it. So it used to be thought that it was not possible to write good programs in JavaScript. The language is so silly and so weird and so full of design errors that it just isn't possible to write good programs, so there's no reason to even try. What we later found out was, not only is it possible to write good programs in JavaScript, it is necessary. Because JavaScript programs can so easily get messed up, requires more discipline than other languages in order to write good code. You need to be using that discipline constantly with this language. There are two sources of confusion among programmers. The first is the fantasy of infallibility. You see this a lot, especially in younger programmers who think, I'm just so awesome. My skills are so complete that I can write code which is crazy, crazy, and it just works because I'm just so awesome. On the other hand, you see other programmers who suffer from the futility of faultlessness. You see this especially in old guys, that I've been programming so long and nothing ever works. So what's the point of even trying anymore, right? It's just all. So it's two different outlooks, but they both end in the same place, and that is in danger-driven development. And using features of the language which increase the likelihood that you're going to make mistakes, either because you think, I'm not going to make the mistake, or because there'll always be mistakes, it doesn't matter. For example, JavaScript's got the semicolon, which it would have been better had Brendan designed a language that didn't have semicolons at all. But instead he used C-like syntax, so he couldn't remove them entirely, but he wanted to make the language easier for beginners, because beginners have trouble in knowing where in C syntax to put the semicolons. But he got it wrong. And so semicolon insertion sometimes works, usually works, but sometimes fails. And if you rely on semicolon insertion, it's likely that someday either you or someone who's maintaining your code is going to get screwed up by it. So I recommend always put the semicolons in your program unless you want your programs to look like they were written by a beginner. If you want your programs to look like they were written by a beginner, then leave the semicolons out. But that's not a mistake that a professional would make. So one of the things that makes it difficult to manage programming is accounting for two specific periods of time. The first is the time that it takes to write the code. And it's difficult to estimate how long that's going to take. The best we can do is try to reduce the scale of the work so that it fits within a week or two. And then we can get fairly good at estimating that. But anything bigger than that, we just don't know. But then there's the other time, which is the time that it takes to make the code work right. And that's even harder to estimate. Ideally, that time should be 0. You wrote the code and it should work. But it doesn't usually happen that way. Sometimes it takes longer than it took to write the code to make the code work. Sometimes it takes infinitely long. And I mean that in the sense where the code gets finished, but it never gets to work right and the project is canceled before they ever get to the point where it's deployable. You could say then time B is infinite. Ideally, we want time B to be 0. So if you do anything in time A, which increases the uncertainty in time B, then you're doing it wrong. We should be doing things in time A, which guarantee that time B is going to be 0. So we should always take the time to code well. Sometimes there's this notion that, well, let's just do it sloppy and get it done fast. But it turns out you still have to make it work. And if you make it sloppy, it's going to be harder to make it work. So it turns out that it's never a good idea to do anything except good coding. So given all of that context, we've got some new features in the language coming out in the 6th edition of ECMAScript called ES6, and that's coming out next year. And ES6 is going to have some good parts in it, some really good parts, and it's going to have some bad parts. So I'll talk about some of the good parts that we're going to have. The first one, my most favorite feature in ES6, is proper tail calls. What that means is, if the last thing a function does is return the result of calling another function, including itself, in the compiler, instead of generating a call return sequence, will instead generate a jump. And that executes much faster, it's less code, but also it eliminates the need to create a new activation record every time we call a function, which means that
the code can go really, really fast. That's going to be brilliant. It will enable continuation passing style and other modes of programming. Once we get this feature, JavaScript will be a real functional programming language. There's the ellipse operator, ... which will replace the arguments array, which was terrible, and allow us to deal with functions that take a variable number of arguments. So here I've got the curry function written two ways. One, the way it works in ES6, and the other, the way it works in ES5. And I'm not going to explain what ES5 is doing, because that's just inexcusably bad. There's all this stuff in there like slice and call and arguments and concat and apply, all these things which have nothing to do with the curry function, which are just awful. Whereas in the new language, I say the curry function takes a function and any number of arguments and returns another function that takes any number of arguments and returns the result of calling a function of any number of arguments and more arguments. And it's perfect. I mean, it's just lovely. So I'm really looking forward to that as well. This doesn't allow us to do anything that we couldn't do before, but we can do things so much better. And that's a good thing. We're going to have a new module system. One of the problems with JavaScript is it's all about global variables. And global variables are evil, and so we don't want to be using them. The module system will allow us to load independent compilation units and allow them to bind to each other without depending on global variables, and that'll be a really good thing. We've got a new let statement. Let works exactly like var, except it will respect block scope. Now, it turns out you don't need block scope to write good programs. You can write good programs using function scope and var. But the reason I like let is that a lot of people come to JavaScript from other languages, and virtually all of the other curly brace languages have block scope. So when they get to JavaScript, they assume it has block scope too, and it doesn't. And if you use var assuming you've got block scope and you don't, that causes confusion and errors. So I will recommend that we stop using var and we use let, because that confusion will be avoided. And I like anything which eliminates confusion. We've got a new thing called deconstruction, where you can create new variables or new parameters and initialize them with the result of some object. So this is a let of curly brace that and other equals some object is shorthand for let that equals some object dot that and other equals some object dot other. Again, not a big deal. It doesn't let you do anything that you couldn't do before, but it will allow us to express some nice things more concisely. And that, not a huge benefit, but it's nice. And then there's a new thing called weak map. This is probably the worst named feature in the history of programming languages. It's really good. It's the way objects always should have worked. If JavaScript objects had allowed you to use any value as a key, it would have been much better. But JavaScript said you could only use strings as keys. And we couldn't fix that, unfortunately, so we bolted another thing to the language. But this allows you to have objects as keys, and the keys do not act as roots. So it means that if all of the links to a key and a weak map disappear, then that property of the weak map also disappears and gets garbage collected. So that allows you to do things that you cannot do in the language today. So I like that a lot. That's going to be a great feature. The only problem with it is its name. Nobody wants to put something weak in their program. But it's really, really good. This is how the language should always have worked. So that's about it. There may be a couple other things like, oh God, trying to think, what else is good in the language? Maybe, no, I don't know. Definitely we got some bad parts coming to the language. I think the worst of the bad parts of the language is going to be class. Class puts a classical veneer on top of the current prototypal system. And the problem with that is that we put this bad part into the language because there's a lot of demand for it. There are a lot of people who insist on using JavaScript who do not know what they're doing and will never know what they're doing. and they wanted class, and so we put it in. But it turns out it's so much easier not using classes. Classes are the source of a lot of rigidity and fragility and brittleness, and if you just avoid using classes, a whole lot of work is avoided. So the people who are totally into the class mindset, who use this new class feature, will never know how miserable they are. They will never, ever, ever find out. And they will feel completely justified in remaining in their miserable state because it's a feature of the language and they have a right to use every feature. So let's look at some of the earlier things in the language. You know, I've been reconsidering what are some of the good parts. For example, in my book, I recommend not using new and instead using object.create to create new objects. In fact, I managed to get this feature added to the language just so that I could use it, which was great. So I was really surprised to find that I have stopped using it. You know, I went to a lot of trouble to put that into the language for me, and I don't use it. The reason for that is that I stopped using this. And the reason I stopped using this was I did some research a few years ago trying to come up with a safe JavaScript subset. There were a lot of researchers in the about 10 years ago who were working on this very difficult problem, that how can you isolate features of JavaScript such that we can allow a third party to load some code into our application and know that that third party cannot abuse us. There are a lot of other approaches. There was FBJS from Facebook, there was Web Sandbox from Microsoft, there was Caja from Google. They all took the approach of rewriting. You know, they would have a compiler that would read JavaScript and write JavaScript, and the JavaScript it outputted would have lots of indirection built into it and a lot of runtime type checking performance. But we don't tend to revise them based on new realities. And the new reality is that Moore's Law has kept cranking and cranking. We now have gigabytes of RAM in your pocket. You know, and we're counting how many bytes we're allocating per object. Unless you're making millions of objects, it just doesn't matter. And so I think we've got some premature optimization going on here. Now, on the other hand, there are problems with it. For example, there's the confusion between own and inherited properties, and I've seen problems come from that confusion. There's also a thing called retroactive heredity, where you can change what an object inherits after it's been constructed. That's just something that falls out of JavaScript's implementation of prototypes. There's no good reason for being able to do that. Not that I've found yet anyway, but lots of bad ones, because it makes it harder to reason about what a system's actually going to do, because at any time the fundamentals of the system can be altered in a way that you can't predict or control. And it's particularly bad in terms of performance. We now have JavaScript engines which are getting to be really fast, which is amazing and wonderful. And one of the ways that they do that is by making assumptions about the shapes of objects. But they have to be pessimistic about what an object might inherit. And so prototypal inheritance is actually limiting performance. If we got rid of it, if we could get rid of it, things could go faster. So I no longer think that the important idea, the important contribution of JavaScript, the thing that makes JavaScript significant, is not prototypal inheritance, it is class-free object-oriented programming. I now think that the idea of mixing functions and data together in the same object was a necessary stepping stone, but it should not have been the end state. And I think I see it as a transition state. So let me explain that a little bit more. So this is block scope, right? We've got two blocks. We've got the inner block and the outer block, and the inner block can see the stuff in the outer block. Right? Everybody knows that. That's how block scope works. And we can make functions work the same way. So we've got two functions, an inner function and the outer function. The inner function can see the variables of the outer function. And if we express the relationship in terms of set diagrams. So that's the set of variables visible to the outer function, and that's the set of variables available to the inner function. So in terms of set, we can say that the inner function set closes over the outer function set. And so that's where we get this word closure to describe the relationship between nested functions. All it means is that the inner function gets to see the stuff of the outer function. Now this gets interesting if the inner function survives the invocation of the outer function, as we would have in this case, where the green function returns the yellow function. So at that point, the green function's invocation is stopped, but the yellow invocation can still happen, and it will still have access to the variables of the outer function. And this is a little, it was weird for a while. It turns out it's easy if you get rid of stacks. If you allocate everything on the heap, then it's just trivial. And this turns out to be one of the most important ideas in the history of programming, where we can have one function that returns another function. So based on this, this is how I am going to be writing constructors in ES6 using some of the new syntax that's in ES6. So now I have my constructor function. I'm going to pass into it an object which will describe what it's going to construct. Usually we'll pass in a bunch of parameters. Some years ago I wrote a terrible constructor that took 10 parameters. And it was awful because nobody could remember what order they went in. And after a while we discovered that nobody needed the third parameter, but we couldn't take it out because we were just stuck with it. It was just awful. What I should have done was pass in a descriptive object which would say this is what we want to make, and it could have named properties, and we could have interesting defaults, and we could add new ones in the future and remove ones that we didn't need anymore. You know, it'd be perfect. So I'm recommending that now, and I'm using the destructuring operator that I showed you before, where I've got my spec object. I can initialize a member variable with spec.member, and I can have as many names as I want. So it's a very convenient method for saying make a new variable that is initialized by a property of the object that is the same name. And then I can call other constructors, in fact, as many of these as I want, and create additional variables as well. And I can even pass in the same specification object. So some of the properties in the specification object will be used by my constructor, some will be used by the other constructor, some will be shared by both constructors. Then I create my methods as well, and my methods will use closure so that my methods will have access to all the other members and all the other variables and all of the methods. No, this is used anywhere in here. In the last step, I return an object, and there's a shorthand notation that we have in objects now. So instead of writing method colon method, I can just write method. Instead of other colon other, I can just write other. And I'm then going to freeze it so the object is immutable. It can still have state. All of the state is living in these member variables, but the object cannot be tampered with. So it means we've got an object which is highly reliable. And highly reliable objects are really good for writing reliable systems. They also have very nice security properties as well, because you can't get at any of the stuff in the object except through the interfaces that you return in the frozen object. So this is how I'm going to recommend writing everything in ES6. So I'm very sad that the language is not going to be done this year. I'm hoping it gets done next year. So I have to confess, I made a bug once, and I have to tell you about it. So in 2001, I wrote a Java package of a reference implementation of JSON. And in it, there was a parser which would take a text or a stream, and it would parse it and return a JSON object. And it contained a variable called index, which counted the number of characters into the stream so that it could report where an error happened. At the time that I designed this, my use of JSON, I never had a JSON text that was bigger than a couple of K. Last year, I got a bug report from someone who had a JSON text that was several gigabytes in length. I never imagined that. At the time that I wrote the package, disk drives, I think, were about a couple of gigabytes. It was just, you just couldn't imagine anything that big. And it turned out they had a syntax error in their text past 2 gigabytes. So my code produced an error and said the error was at minus some weird, unlikely number, which was wrong. And I was really embarrassed about that. So what went wrong? The problem is that int. Ints, I think, are one of the worst ideas in the history of programming. Why are they so bad? It's because of what they do when they overflow. You know, so let's step back. So what should happen if you have a number that's too big to store into a variable? What should happen? One possible theory would be the computer should halt. That's maybe too drastic, but at least you're not going to generate any bad results. Maybe better be it'd raise an exception. That'd be pretty good. Another would be it'll return a NaN value, which says, sorry folks, don't know what you're expecting, but this isn't it. For some applications, you'd say, let's put in the biggest possible number that we can. This is called saturation, and that makes sense in computer graphics and in signal processing. You don't want to do that in financial applications. What's the worst possible thing you could do? I think it would be to throw away the high order bits and not tell anybody. And that is what we do. It made sense in the 50s. So in the 50s, computers were built out of vacuum tubes. Vacuum tubes are big and expensive, and they draw a lot of power, and they burn out pretty quickly. So the more tubes you had in your ALU, the more the thing was going to cost, the more it cost to operate, and the faster it was going to fail. Some really smart guy figured out if we use complement arithmetic, we do not have to implement a subtract circuit. We can complement and add and ignore the overflow. So great. That was a brilliant thing to do in the 50s. And we're still doing it. And there's no reason to. Moore's Law has given us so many devices, there's just no reason to keep doing this optimization, but we keep doing it. We can't stop. There's no point where we stop. You know, I think every 50 years or so, we should look at our computer architecture and say, are we getting this right? Because I don't think we are. Also, they now come in lots of different sizes. And there was a time when that made a lot of sense. Memory used to be really expensive and really scarce. But again, you've got gigabytes in your pocket now, so trying to optimize how many bytes you're spending in a variable is a complete waste of time. So in Java, you got byte, char, short, int, long, float, and double. So every time you create a new member or a new parameter or a new variable, you have to decide, which one do I want? You should be spending your time doing more important things. That's just a complete waste of time. If you get it right, then the program will work, and if you get it wrong, it fails. But it looks like it's not long now, so that's going to happen. Now, thank you. And basically, that's happening because of you, right? I mean, you looked at XML and said, no, I don't want to do that either. You know, I want to do this thing. You know, so that's the way it's going now. So I never intended for JSON to be the last data interchange format. I intended it for a very specific purpose, and I wanted to have only good parts in it, so I left out a lot of stuff. You know, I subtracted everything that I could, tried to make it as small as possible so it could do this one thing really well. Now, it's now being asked to do a lot of things that it was originally not designed for, so I expect there are going to be new formats which will do those other things. I never intended for JSON to be the end of the line. So I have some advice to data format standard designers. Again, just like programming languages, I think everybody should be designing standards and you know, get as many ideas out there until we can find a good one. So I've got some advice. The first one is, please don't break JSON. So one of the best features in JSON is that it doesn't have a version number. So there's no way to revise it without breaking everything, which means we're never going to revise it, which means that it's stable. You know, it's going to work till the end of time, which is great. You know, everything else in the stack is going to break. There's that one little bit of it that's going to be stable forever, and that's pretty good. I can't think of any feature we could add to JSON which is more valuable than that. So we're going to keep that. So when you're designing your next data format, don't do something which requires breaking JSON. Figure out another way to get there. Make it significantly better. Don't make it just a tiny bit better because there's no reason for people to pay the migration.
Douglas?
I'd love to take questions.
Yeah, so we'll just have 3 questions for Douglas, so go ahead and shoot.
Yeah. Have I used CoffeeScript?
No, sir. What's your advice for?
What do I think about CoffeeScript?
Yeah.
So CoffeeScript is a brilliant experiment. I love CoffeeScript. I recommend everybody learn CoffeeScript because CoffeeScript is a dialect of JavaScript that has much better syntax, which makes it much easier to recognize what the good parts of JavaScript are. It used to be said that no new programming language could succeed unless it looked exactly like C. And CoffeeScript, the best thing about it is it doesn't look like C. And it's being very successful. And so that gives me hope for the future, that new languages don't have to look like C anymore, which is brilliant. All of that said, I do not recommend using it in production. It's a brilliant experiment. I think it's a successful experiment, but I don't think it's a production tool. It makes things in the enterprise even harder because now you have to find people who are going to maintain CoffeeScript. It's hard enough to find people who can write JavaScript. So it's just not worth it. There's nothing you can write in CoffeeScript that you can't write in JavaScript. I still recommend everybody learn CoffeeScript and then forget about it and you know, it can teach you things, and learn the things it will teach you, because they're good and important, but don't put it in production. Anybody else?
Yeah, we have one more question here.
Okay, I can't see you.
Yeah.
Okay, shout out.
Hello, Douglas. Thank you very much for sharing the better parts on top of good parts book that you've already written. So I've seen your video on JavaScript is everywhere from a conference in Europe in 2012. And in that you had mentioned JavaScript saved the web. And that is true, and that is why we all are here today for 2 days. So I would like to say you are one of the guys who saved JavaScript. And it's amazing because of all the contributions you made. So because like you are at the so top, I would like to know how do you foresee this language along with Node.js, which is coming up?
Yeah, so the whole fact that we still have a web and everything is at least partly my fault. So I'm really sorry about that. Sorry. You know, in a perfect world, JavaScript would have died when Netscape died, and we would have moved on to something else. But you know, I deeply believe that the web survived because it had JavaScript in it.